So here we can write this as Laplace inverse of s plus 2 minus 2 upon s plus 2 bracket square plus 9. Okay, and if you further simplify this, what we get here? So that is equal to, by using first shifting property, this can be written as e raised to minus 2t into Laplace inverse of s minus 2 divided by here s square plus 9. Okay, and we know that this example can be solved by using type number 1. So e raised to minus 2t into Laplace inverse of, separate the denominator, s upon s square plus 9 minus 2 upon s square plus 9. Okay, now if you further simplify this, what we get? E raised to minus 2t into, okay, what is this? This is nothing but your Laplace inverse of s upon s square plus 9, that is definitely cos of 3t, minus here we can take 2 common, and here 1 upon s square plus 9, that will be 1 upon 3 sine of 3t. Okay, this is Laplace inverse of given function. Okay, now let us take another example, example number 4. So let us take example number 4. Find Laplace inverse of 1 upon s plus 3 raised to 3 by 2 plus 1 upon s plus 4 raised to 4. Okay, so now that is equal to, so here there is s plus 3 and here is also s plus 4. So by using first shifting property, we can write this as e raised to minus 3t Laplace inverse of 1 upon s raised to 3 by 2 plus here, okay, here what we can write? So this is for this thing, and here e raised to minus 4t Laplace inverse of 1 upon s raised to 4. Okay, this we can write. So now that is equal to e raised to minus 3t into, what is Laplace inverse of this? So Laplace inverse of this will be t raised to 3 by 2 minus 1 upon gamma 3 by 2 plus e raised to minus 4t into t raised to 3 upon 3 factorial. Now simplify this further, e raised to minus 3t into t raised to 1 by 2 divided by, this can be written as 1 by 2 plus 1, isn't it? Plus e raised to minus 4t t raised to 3 upon 6 is equal to e raised to minus 3t t raised to 1 by 2 upon 1 by 2 gamma 1 by 2 plus e raised to minus 4t into t raised to 3 upon 6, and that is equal to e raised to minus 3t into t raised to 1 by 2 divided by this gamma 1 by 2. Okay, this 2 can be taken outside, at the numerator, and gamma 1 by 2 is root pi plus e raised to minus 4t into t raised to 3 upon 6. Okay, and if you further simplify this, okay, what we get here finally? So finally we can write this as, that is equal to 2 e raised to minus 3t, this is in root and this is also in root, so we can take this both in root, plus e raised to minus 4t t raised to 3 upon 6. So this is your final answer. Okay, got it? So this is very, very simple. Now let us see another types of examples in the same category. So example number 5. Example number 5. Find Laplace inverse of 1 upon s square plus 4s plus 16. Okay, this is a simple example. Okay, now how we can write this? Now let us take here 8. Let us take here 8. Okay, let us make it simple first, and after that we will solve that example. Okay, so now how to simplify this example? So Laplace inverse of 1 upon s square plus 8s plus 16, that is given to you. That is equal to Laplace inverse of 1 upon, this is a perfect square of what? s plus 4 bracket square, isn't it? This is the perfect square of s plus 4 bracket square. Now after that, by using first shifting property, we can write this as e raised to minus 4t Laplace inverse of 1 upon s square. That is equal to e raised to minus 4t into, this is nothing but t raised to 1 upon 1 factorial, that is e raised to minus 4t into t. Okay, so this was the example, simple example. But now let us take the another example, example number 6, in which we just modify it. So find Laplace inverse of 1 upon s square plus 4s plus 16. Okay, let us take that example. Now this is not a perfect square. This is not a perfect square. So in this case, what we have to do? So if this is not a perfect square, then what we have to do? We have to find, first of all, we have to make this perfect square. So how to make it? So for that, to make denominator perfect square, to make denominator perfect square, calculate third term. So how to calculate third term? So formula for third term, tt, okay, tt, that is third term, is equal to coefficient of middle term, that is square, okay, coefficient of middle term bracket square, divided by 4 into coefficient of first term. ft is first term, mt is middle term. Okay, now in this case, third term is equal to, what is the coefficient of middle term? 4. So 4 square divided by 4 into, what is the coefficient of first term? That is 1. So 16 divided by 4, that will be 4. So third term is 4. So once you get the value of this particular third term, then how to use this third term? So Laplace inverse of 1 upon s square plus 4s. Okay, so this term you have to add and subtract. You have to add and subtract. Okay, remember this. Now once you add and subtract this, what we get here? 1 upon, now this is a perfect square of what? S plus 2 bracket square, and here it is 12. 16 minus 4 will be 12. Okay, so now after that, if you see this, okay, so this can be written as Laplace inverse of 1 upon s plus 2 bracket square plus 12. Okay, so this we have got. Now if you observe this, this is s plus 2. So here now we can use by using first shifting property, and this can be written as e raised to minus 2t into Laplace inverse of 1 upon s square plus 12. Okay, and this can be written as finally e raised to minus 2t into 1 upon root 12 bracket square into, this can be written as sine of root 12t. Okay, so now this can be written as, sorry, not square here, sorry. So e raised to minus 2t into sine of root 12t divided by this 12, root 12 can be written as root 4 into 3, and finally this can be written as e raised to minus 2t into sine of root 12t divided by 2 root 3. Okay, this is 2 root 3, and this is the answer. Okay, so I hope you got this particular example. Now let us take example number 7. Find Laplace inverse of s plus 2 divided by s square plus 3s plus 9. Okay, now we have to simplify this example. How to simplify this? That is equal to, please see carefully. Okay, so now let us first check whether this particular denominator is of perfect square or not. So this is not a perfect square. So first of all, we have to make this perfect square. How to make it? Look at this. So to make denominator denominator perfect square, find third term. Find third term. And how to find third term? We know very well. Okay. So third term is equal to coefficient of middle term bracket square upon 4 into coefficient of first term. Now that is equal to, what is coefficient of middle term? 3 square upon 4 into 1, 9 upon 4. Okay, so this is sorry, this is the third term. Now add this third term and subtract this third term from the given question, from the denominator. So Laplace inverse of s plus 2 upon s square plus 3s plus 9 by 4 we have added, minus 9 by 4 we have subtracted, and there is 9. Okay. Now if you simplify this, what do we get? Laplace inverse of s plus 2 divided by, this is what? Now s plus square root of this will be 3 by 2 bracket square minus 9 4s are 4 9s are 36, 36 minus 9, that will be 25 divided by 4. Okay, so plus 25 divided by 4. 36 minus 9 will be, what is that? I think this is wrong, this is 27. Okay, this will be 27, sorry. 9 4s are 36, 36 minus 9, that will be 27. 27 plus 9 is 36. Okay, good. So now what we have to do here, if you say this, what we have written here, Laplace inverse of s plus 2, okay, divided by s plus 3 by 2 bracket square plus 27 by 4. Now if you observe this, so there is s plus 3 by 2, isn't it? So this s plus 3 should be at the numerator, so we have to adjust it. So Laplace inverse of s plus 3 by 2 we have added, minus 3 by 2 we have subtracted it, and plus 2 is already exist, divided by s plus 3 by 2 bracket square plus 27 by 4 bracket close. That is equal to Laplace inverse of s plus 3 by 2, 2 to the 4, 4 minus 3 will be 1, so 1 by 2 will be there, divided by s plus 3 by 2 bracket square plus 27 by 4. Now here we can use first shifting property. So by using first shifting property, this can be written as what? E raised to minus 3 by 2 t Laplace inverse of s plus 1 by 2 divided by s square plus 27 by 4. Okay, now this is example of type number 1. So e raised to minus 3 by 2 t, if you separate this, what we get? Laplace inverse of s upon s square plus 27 by 4 in first bracket plus this 1 by 2 can be taken outside, Laplace inverse of 1 upon s square plus 27 by 4 bracket close. Okay, now this can be written as e raised to minus 3 by 2 t, what is this? Cos of root 27 by 4 t, right? This is the inverse Laplace transform of this function, plus 1 by 2 into, okay, 1 divided by root 27 by 4 into sine of root 27 by 4 t, right? Now if you further simplify this, what we get? If you further simplify this, what we can write this? So this can be written as e raised to minus 3 by 2 t in bracket cos of root 27 divided by 2, because this 4 can be taken outside, plus, okay, this is 2 and this 2 get cancelled, and here only we can get here 27 sine of root 7 divided by 2 t. This is the final answer. Okay, so in this way we can solve such type of examples. Okay, I hope you got it. Now let us take some examples for homework. Example number 8. find Laplace inverse of 1 upon a square plus 2s plus 5. So this is first example we have to solve. Next example, find Laplace inverse of 2s plus 1 upon a square plus 4s plus 4. Okay, so you just try to solve these examples at home. Okay, now in next lecture we are going to study the second property of the inverse Laplace transform, that is second shifting property. Okay, thank you very much.